Hi everyone, this video is going to cover some of the big ideas for Unit 6 that we have learned so far. We've spent a really long time on Freefall Lab learning lots of valuable lab skills, but I think it's important to kind of zoom back out and see the big picture of the physics content that we've learned so far too. So I'm going to divide this into two categories. First, we're going to talk about constant velocity. So this is going to be our constant velocity column. And then after we do that, we're going to come back and talk about changing velocity. So this will be our changing velocity column. Okay, so let's begin over here in constant velocity. For an example, you might think about Buggy Lab from last unit for constant velocity. That buggy was going at a constant speed in the same direction, a constant velocity. Now, one thing that we know from Newton's first law, an object in motion stays in motion, an object at rest stays at rest unless there's an unbalanced force, is that because our buggy was in constant motion at a constant velocity, the forces must be balanced. So we know balanced forces are associated with a constant velocity. Now for our buggy, it was moving at a constant velocity of some number, but it could also mean a constant velocity of 0 would have balanced forces. Now, back in Buggy Lab, we drew a graph. The first graph that we drew was a time versus displacement graph. And if you remember on that time displacement graph, we saw a linear pattern, something like this. That linear pattern here was showing us constant velocity. And if you recall, the slope on a displacement time graph represents, it is the velocity. If you ever forget that, you could always check the slope units. Slope units we get by doing rise over run. On this graph, we rise in meters and we run in seconds. These are the units of velocity. So it makes sense for my slope to be velocity. Notice that on this particular graph, because it's linear, we have one constant slope, so we have one constant velocity. Another way of seeing constant velocity is to think about velocity as being the change in displacement over time. So you could start to look at different points on this graph, noticing that to get from one point to the next point, as long as your change in time is the same, your change in displacement will be the same. And so your displacement is increasing by the same amount each time. That shows constant velocity. Another way of representing constant velocity is to look at a different type of graph. This graph is going to be a time versus velocity graph. Notice that switch in the y-axis. On this time velocity graph, for constant velocity, we would see a flat line pattern. Let's do a double check just by thinking through some values here. Let's say that this velocity value just happens to be 2. And I'll label up some times just to help us talk about it. At 1 second, my velocity is 2 meters per second, just looking at that y value. At 2 seconds, my velocity is still 2 meters per second. And at 3 seconds, my velocity is still 2 meters per second. And at 4 seconds, my velocity is still 2 meters per second. This is still showing us constant velocity. But now we just have to look at the y values to see that. As we have learned, the slope on a velocity time graph, the slope represents acceleration. how is the velocity changing over time? If you ever forget that, you could look at the units, doing rise over run, rise in meters per second, and run in seconds. Or this simplifies to meters per second squared, our units for acceleration. Notice here on our flat line graph, our slope is 0, so our acceleration is 0, meaning our velocity doesn't change. So this is our constant velocity column. We have displacement time graph, we have a velocity time graph. We can notice that there are balanced forces that are causing this constant velocity. This was all talking about Buggy Lab, or it might remind you a lot of your formative. So let's transition over to the most recent things that we've learned, which involve changing velocity. For example, we have been seeing changing velocity in our free fall lab. Now, coming back to Newton's first law, an object in motion stays in motion, an object at rest stays at rest unless there's an unbalanced force. What's causing the changes in our velocity is an unbalanced force. In our free fall lab, this unbalanced force was gravity, and no air resistance that's significant enough to balance it out. In part 1 of our lab, we created a time versus displacement graph. And instead of seeing a linear pattern like we saw before, we saw a quadratic pattern. Now, just like before, the slope on my displacement time graph still represents velocity. And again, if you ever forget that, just take a look at the units, rise over run, rise in meters, run in seconds. Meters per second being the values for our velocity. The units for our velocity. So let's make sure that we understand how this quadratic graph is showing changing velocity. Well, we can see it in kind of two different ways. The first way is to think about the slope being velocity. The trick here is we don't just have one slope like we used to have with a line. We would need to draw in little slope chunks, and those little slope chunks are ideally tangent to the curve. Tangent meaning they're touching at just one point. And if we can find the slope of each of those tangent lines, then we can know the velocity at each of those moments. Just taking a look visually at these tangent lines, it looks like my first tangent line down here has a slope of pretty close to 0. It's a nice flat line. But then the slope gets a little steeper. My velocity gets a little bigger. And a little steeper, my velocity gets even bigger, and steeper, and my velocity gets bigger, and steeper, my velocity gets faster, until I'm going really steep slope, really fast velocity. So by looking at these little slope chunks, we can learn about the velocity and how it's changing over time. Another way of seeing how the velocity is changing is to think of velocity as being the change in displacement over time. Let's see, for every time that passes, my displacement is going to get bigger. But I want us to focus on how it's getting bigger. I want us to focus on the changes in displacement. Do you see how my displacement is getting bigger and bigger? The y values are getting bigger and bigger. But notice that it's getting bigger at an increasing rate. It's increasing by a larger amount each and every time. meaning that if the displacement is getting bigger by a bigger amount each time, my velocity, how displacement is changing, must be increasing. Part 2 of this lab, we then changed our perspective and we started to make a time velocity graph. And on this time velocity graph, we got a linear pattern. Remember, the slope on a velocity time graph represents acceleration. And if you ever forget that, just look at your units rise over run, rise in meters per second, run in seconds. Simplifies to meters per second squared, the units of acceleration. Now this graph too shows changing velocity, and we can see that in 2 different ways. The first way, we could look at the slope and say, hey, this line has one slope, so this line has one acceleration. The acceleration is constant. Now remember, acceleration is a change in velocity per time. So if we're always accelerating, we're always changing the velocity per time. The second way to see this is to actually look at some values. I'm going to draw some in just to help us talk about it. With these values, you can see at 1 second on this graph, the velocity is 10 meters per second. And at 2 seconds on this graph, it's 20 meters per second. And 3 seconds is 30 meters per second. 4 seconds is 40 meters per second. My velocity is going from pretty slow, 10 meters per second, to faster, 20 meters per second, to faster, 30 meters per second, to faster, 40 meters per second. We're seeing a changing velocity. Now, if you look at how the velocity is changing, that's where we get back to acceleration. The velocity is changing by the same amount each time. That's showing us the constant acceleration. Let me zoom back out here so we can see the big picture. On the left, we have constant velocity. Where we see balanced forces, a linear displacement time graph, and a flat line velocity time graph. On the right side, we see changing velocity caused by unbalanced forces, giving us a quadratic displacement time graph and a linear velocity time graph. I'd really encourage you not to just memorize these patterns. Instead, try to use a brain thinker and try to think through what would each point on this graph mean? What would the slope on this graph mean? And use that as a guide for understanding the motion and the forces behind whatever object.